Today, we're talking about structural recovery, how to bring your data back to a healthy, trustworthy state after structural problems, and how to do it in a way that's repeatable, safe, and confidence-restoring. This episode is pragmatic and example first, so whether you're firefighting an incident or building systems to recover faster, you'll walk away with concrete steps. First, let's set a simple distinction. You've already heard about fragmentation, collapse, partial loss, corruption, and repair. Recovery is the broader operational process that includes repair, but goes further. It's about restoring business continuity, verifying correctness, communicating clearly, and returning systems to a state where both machines and humans trust the data again. Here's a short story. Overnight, a migration introduced inconsistent user identifiers in the analytics stream. Reports were wrong this morning, and a live dashboard drove a business alert. The team needs to restore daily reporting, ensure models aren't poisoned, and prevent recurrence. Structural recovery is the playbook for doing that reliably. Step 1. Detect and scope quickly. Trigger meaningful alerts early. Schema health anomalies, sudden drops in join rates, spikes in nulls, or reconciliation mismatches. Once alerted, capture the blast radius. Which entities, which tables or partitions, what time windows, and which consumers are affected. Snapshot the current state immediately. Exports or immutable copies are essential, so you can experiment without losing evidence. Step 2. Establish an incident cadence and owner. Assign a single incident lead, communicate status to stakeholders, and set short sync intervals. Recovery requires coordination between data engineers, product owners, analysts, and sometimes vendor support. Clear roles speed decisions. Step 3. Choose the right recovery mode. There are 3 common approaches: rollback, replay, and targeted repair. Rollback. Revert systems to a known good snapshot when changes are recent and reversible. It's fast, but only possible if you have snapshots, and the business can tolerate the rollback window. Replay. If you have append-only logs or raw event stores, re-ingest from a safe point applying corrected transforms. Replay is deterministic and preserves intent. Targeted repair. For localized damage, run idempotent patch jobs that fix specific fields or reconcile aggregates. This is useful when only parts of the dataset are affected. Pick the least invasive option that restores correctness quickly. Step 4. Validate thoroughly before promoting fixes. Don't rely on a single test. Compare repaired data against authoritative sources, rerun critical reconciliations, and check downstream dashboards and models in a staging environment. Use acceptance criteria tied to business KPIs. For example, totals must match reconciled ledger amounts, or user counts must align with CRM for the affected time window. Step 5. Staged rollout and monitoring. Deploy fixes behind feature flags or in canary slices, small subsets of data or users, and watch metrics closely. A staged approach lets you catch residual issues without impacting everyone. Maintain tight monitoring on both technical health, schema integrity, ETL success rates, and business signals. Reconciled totals, conversion metrics. Step 6. Communicate and restore trust. Publish a clear incident summary for stakeholders. What happened, who was affected, what you changed, and what remains to be verified. Provide timelines and, crucially, evidence, reconciliation reports, before and after metrics, and test results. Transparency shortens the window of distrust. Step 7. Harden and automate the recovery path. Treat recovery itself as productizable. Codify repairs as idempotent jobs, automate replay procedures, and create pre-built queries for scoping damage. Maintain runbooks for common scenarios and keep them current. Include scripts for snapshot creation, replay commands, and verification queries so your next recovery is faster and less ad hoc. Engineering patterns that accelerate recovery. Append-only event stores or raw logs enable deterministic replays. Immutable snapshots and golden record backups give you safe rollback points. Idempotent repair jobs and migration scripts, repeated runs don't create extra damage. Validation at ingest and contract testing, catch issues before they spread. Lineage and observability, trace which upstream change caused downstream problems. Organizational practices matter just as much as tech. Designate domain owners with SLAs, run tabletop drills to practice recoveries, and require post-mortems that include remediation and prevention plans. Make recovery playbooks visible to the teams who will execute them. A few practical tips from the field. Cautious when authoritative sources conflict, prefer conservative outcomes, and mark uncertain records as quarantined or imputed rather than overwriting blindly. Preserve provenance and audit trails for every repaired row, who changed it, why, and from which source. This matters for compliance and for debugging later. Measure time to trust, not just time to fix. Getting systems back online is one thing, getting humans to trust them again is another. To wrap up, structural recovery is a disciplined sequence: detect and scope, own the incident, choose the least invasive recovery mode, roll back, replay or targeted repair, validate in staging, roll out in stages, communicate clearly, and harden systems so recovery is faster next time. Build the automation, own the domain, and keep the evidence. That combination turns painful incidents into manageable operations. Thanks for watching.